So we did talk through 5, I think, in class yesterday. That was E. Questions on that, like why it's not B? Because B can be negative, but I could find a value where it wasn't negative, so it's not B. It had to be E because it's always negative. 6, which is this the slope field for? And we said in class yesterday that C and D were always positive because of the absolute value. That left B, and if we could find values that made sense or broke it, then like counterexamples, then we knew it wasn't that. I found one for B. Then we were left with A and E, and I just did some more math to sort of pin it down. If you want to see it graphed, I did go to, so here's Desmos's confirmation that it's A. I didn't circle it. Here we go. A. Well, that'll be bad. I want to post it. Anyway, A. 7, match the slope fields and draw in stuff. So I've got 7 is A, 8 is C, 9 is B, and 10 is D. 10 was the easiest for me to do. It was a circle. That's the one I had on the board yesterday, so I was able to go through that. Then they wanted us to graph or try to draw in the solutions. And for a minute, I got confused with drawing in for A because I was like, well, what if I connected the lines here? It wouldn't be a function anymore. But this is slope field for anything. So if they had put the dot over here, I would have drawn the line over here, not necessarily where mine is. And I don't know how close that is, but it's just a close approximation for what it should be. Did it already break? The circle's obviously my favorite because that's easy to see. This is like just one piece of that. This looks like it's following an asymptote and then a vertical asymptote. Going through all those dots. How about that? Does that make sense to you a little bit? Yeah, cool. That's the end. The end. So there's a little bit more practice with slope fields tonight in our section, but we're also going to do some solving of differential equations. So we've got some new notes. Lucas, you have one of these, so I don't need to give you one. You printed it like you have it. So if you're looking in the book, the title of this is called Slope Fields and Euler's Method, the same guy that E is named after, but Euler's Method is a BC topic, so we do not need to do it in this section now. So we're only going to be doing slope fields and verifying solutions. So this is 6.5. It's really not 6.5. Sorry, in my head, I'm in Algebra 2. 5.1 or precalculus. They're in the same section. Okay. Verifying solutions. This is called slope fields. It's kind of a misnomer because there's other stuff in here. So part of what you're doing tonight is looking at slope fields. Part of what you're doing tonight is verifying solutions to differential equations. So we're going to look at the verifying now because we've already looked at slope fields. So verifying solutions to differential equations. So here's a differential equation. Y double prime minus y equals 0. It's a differential equation because it has a derivative in it. That's all it means. So what does it mean to be a solution to differential equations? Let's see, we've got these 3 different things we're going to check. A, we're going to see if y equals sine of x is a solution to this differential equation. Meaning, we're going to see if this works in here. In order for me to plug stuff in from this into here, I have y. What else do I need? I need y double prime. So I need to go take a derivative. Y prime equals cosine of x, so y double prime is negative sine of x. So now I have all the pieces required to verify it and see if it is true or not. So I go over here and I say y double prime is negative sine of x minus y sine of x equals 0. Is that true? Not true. We know that because I made you define solution like 5,000 times, that if it can't plug it in, and if it's not a true statement, then it's not a solution. So this is not a solution. Let's try another. We have y equals 4e to the negative x. So what are you doing? We're plugging in the same equation, still y prime minus y. So you need to take a derivative twice, see what you get. Go for it. You can take a derivative and take a derivative again. So I've got y prime equals 4e to the negative x times negative 1, which is negative 4e to the negative x. Y double prime is negative 4e to the negative x times negative 1 again, so that's going to be 4e to the negative x. So I got the same thing back out. Convenient. Now I'm going to plug it in here. I'm plugging it into y double prime minus y equals 0. Y double prime is 4e to the negative x minus y is 4e to the negative x. I have 4 of something minus 4 of something, that's 0, and that's true. 0 equals 0, so is a solution. How about that? Did you get that? Does that make sense? Back to A, I have seen multiple choice questions where they're like, what is the 28th derivative of sine of x? How would you do that while we're here? Yeah, so you need to find the loop. Remember how we did I squared, I cubed, and then it repeats. So this would be the same thing. This would be sine of x. This y prime is cosine. Y double prime, negative sine. Y to the third derivative is negative cosine. Y to the fourth is sine. So it's the same as I. Every fourth, it repeats. So that's all you need to do. So what's the 28th? The 28th goes in 0, so it's the same as y to the fourth. Y to the fourth. Y to the fourth is sine. Yeah. 1, 2, 3, 4. Okay. Yeah. And then if it had a leftover of 1, it would be up here. Wait, here. If it had a remainder of 2, it would be here. Remainder of 3, it would be here. If it had 0 remainder, it would be back to here. Yeah. So, just so that doesn't confuse you and you don't spend like an hour taking 28 derivatives. Trick there. Okay, back to the actual section we're in. C says y equals, and this is sort of setting us up for what we're going to do soon, c e to the x. That means any constant, e to the x. What's its derivative and second derivative? The same thing. So you're going to end up with a problem just like this. Y double prime is c e to the x. So you're going to have c e to the x minus c e to the x equals 0. 0 equals 0. True. Doesn't matter what c is. That's going to work. So that's convenient. How about that? Does that make sense? So if they ask you, if I ask you, if anyone asks you, is it a solution of, you need to find all of these pieces and then test them out and see if they work. So you're just going to prove it is or is not a solution. Let's see what else we got. For this, my pen is dead. Xy prime minus 3y equals 0. Verify that, pen is dead. Y equals cx cubed is a solution. Then find the particular solution, where y equals 2 when x equals -3. So let's try it out. What do we need to do first? So we need to have y prime. Yeah? What's y prime? Y prime equals 3cx squared. So we already have y prime and y. We're going to leave x here. We don't have to resolve it backwards. We're just going to leave x how it is and plug in this and this. So write that down. See what you get. So we're going to keep x just how it is. Just trying to solve for y. So we're just going to use this information for y and y prime. You're going to leave x how it is. Okay, so first, I'm just plugging in y here and y prime here. So 3cx squared. And then regular y is cx cubed. That's going to be 3cx cubed minus 3cx cubed equals 0. That's true. Now I have to find the particular solution. So I'm trying to solve for c right here. This is my original equation that solves this over here. I'm trying to find out what the particular solution is. So like if I graph the slope field or whatever, I could find the actual c value and say that's the one equation that I'm talking about. Because these values go with it, meaning I have a point. They sometimes list it randomly, like not a point. You should put it back in point form so it's easy to plug in. And we're trying to solve this for c, that constant. In this case, it's multiplied by, not addition to. So we're going to say 2 equals c times -3 cubed. 2 equals negative 27c. c equals 2 over -27. So our function with c plugged in is y equals 2 over -27 x cubed. So for homework, you have problems like that. You have a couple of slope fields that you need to match. So I think they've given you 4 and 4 equations that you want to solve for. And then they've got this idea of here's a differential equation. see if these functions work or don't work. So you're going to verify and just go through examples like these. So your problems are a mystery. Do what? Oh, convenient.